Hello everyone, we're going to do this little review video that I promised about how to draw dot diagrams, and I'm going to show you how to complete the chart over to molecular geometry. So taking a look over here at our dot diagram list, I'm going to do number 22 and number 23. So two examples and just take you all the way through the chart. Once again, number 22, SO3, number 23, SO3, -2. So SO3 and SO3 -2. Since this pencil is going to be difficult to draw with, I'm going to draw the dot diagram down below. So here's SO3. If I add up the valence electrons, I got 6 plus 6 times 3, so I'm going to have 24 valence electrons. I set up my skeleton structure over here on the left side. I put in 3 bonds, I put the O's around, and now I have, of the 24 valence electrons, I've shown 6 in my picture, so I have 18 to distribute. You can probably tell that if I put 6 here, 6 here, and 6 here, that would give me 18. Well, 18, that 6 here makes 8 for the oxygen, and 6 here makes 8 for that oxygen, and 6 here makes 8 for that oxygen, but I still need 2 more for the sulfur that I don't have, so I'm going to be too short. That is, I need 2 more electrons than I really have. So when you're too short, what do? Add a double bond. All right, so then now with my 24 valence electrons, I subtract 8, and I have 16 left. So I'll put in my 16 dots. Only need 4 right here to make that oxygen have 8 electrons around it. And 1, 2, 3, 4, 5, 6. That gives me 8 electrons around this O. And that gives me 8 electrons around that O. So let's double check and make sure that we have 24 electrons in the picture. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So yes, we do. So that's our picture. So the Lewis structure then is this. All right, so for that one, you should have that picture right there. The total domains on the central atom. So we have a domain here. So that's one domain. There's 2 domains. There's 3 domains. So it looks like we got 3 domains. Now, if you remember the little thing we had in class today, I gave you a little sheet. This sheet can be found on the homework section of the website if you lost yours. With 3 domains, so right here, 3, we call that trigonal planar. So the electron domain geometry would be trigonal planar. Whoops, over here. T, P. All right, the bonding domains. Well, in this picture, all of these domains, 1, 2, 3, all of them are bonds, aren't they? So there'd be 3, and there aren't any non-bonding domains because there are no unshared electrons around the central atom. So the 3-dimensional structure is hard for me to model for you exactly, but that one's going to be a flat. So let's go and do molecular geometry, and I'll come back and do that. So for the molecular geometry, if you look and you see that there are 3, we're at trigonal planar, and we've got 3 shared and no unshared pairs. So the molecular geometry is just called trigonal planar, which means it's going to be a triangle in a plane. So if I come over here, we'd call this trigonal planar as well. And what trigonal planar means is a triangle in a plane. So it's kind of like a Mercedes symbol. And that would be your 3D structure. Now let's take a look at SO3 -2, the next chart. All right, so we got SO3 -2. Put our skeleton structure over here. Number of valence electrons, I got 6 plus 18 plus 2, so that's 26. I have 6 in my picture. So if I could put 6 electrons around each O, plus 2 over here. So 6 electrons, 1, 2, 3, 4, 5, 6. Okay, oh, by the way, I forgot to subtract, didn't I? So I have 26. I had 6 in my picture, so take away 6, it gives me 20 dots to put in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I've put in 18 dots. I still need 2 more, but I have them, and they go on the sulfur. So now our picture, I can fit it in there maybe. We won't do that. So our picture, we'll just make it a little arrow. Goes right there. So total domains on the central atom are 4. See them? Right here's one. Oops. Right here's one. Here's one. Here's one. And there's one. So there's 4. So the electron domain geometry when there are 4 domains is tetrahedral. So we'd call this tetrahedral. We just put tet for short. And the number of bonding domains would be how many bonding domains? Let's see. So you go down here, you got a bonding domain here and here and here, but that's not a bonding domain there because that's an unshared pair of electrons. So we have 3 bonding domains and 1 non-bonding domain. So if you go back over here and look at your chart, it'll tell you that when you have tetrahedral electron geometry, but there are 3 bonding and 1 unbonding, right here, 3 and 1, then we call that a pyramidal shape or a pyramidal shape. It'll be a pyramid, sometimes called a trigonal pyramid. Okay, so I'm just going to call this pyramidal. All right, so the 3D structure would be a pyramid. So you'd have one coming down like that, right like that, one like that. All right, so that's supposed to look 3-dimensional. I'm not sure that it does, but you would have a top and then a back behind, and then one out in front and one out in front on this side. So it's a pyramid. And if you'd like to see a picture with the dots shown, you could go to the other link that I posted on the website in the homework section, this page right here. So if you go to tetrahedral, 4 domains, but where 3 are shared and 1 is unshared, there's your pyramidal shape. All right, and one other thing I'll show you while we're on this video. If I go here, if I go to the website and click on Advanced Chemistry, then click on the covalent bonding section, there's this place right here where it says pictures of molecules using JMOL. I'll just post that on the homework real quick. There should have been a link here. Okay, so here's the website. Looks like that. So if I was to type in what I'm looking for, say SO3, I have 2 possibilities. I have the sulfide ion, that's SO3 negative 2, I have sulfur trioxide. Okay, when you pull this up, it's going to show us a picture that doesn't look like what I drew quite. It's flat, you can see it's flat, but instead of having a single and 2 singles and a double like I drew it, see right here, 2 singles and a double, instead the picture has 3 doubles, and we'll talk about why that is in a separate video and probably in the next class as well. So don't worry about that this weekend, and we'll talk about it next class. If on the other hand you did SO3 negative 2, well, let's just call it sulfide ion. It's going to look like this. And once again, I drew it with all single bonds, and this has a double bond, and we're going to learn why that is. But the shape is still the same. It has basically a pyramidal shape, okay, or a pyramid shape. Okay, that's where I'm going to stop this video, and I hope that helps you get these done. So we want to get the first 25 completely finished through the molecular geometry column. All right, have a good weekend.